In underground cable engineering, fifth topic of the third unit is polymeric insulated distribution cables for 6 to 30 kilo. Polymeric insulated distribution cables are normally used in modern medium voltage power distribution system because of their improved dielectric properties, their flexibility, thermal performance, and resistance to environmental stress compared to traditional paper-based cables. Normally, the medium 6 voltage, 11 kilovolt, 6 kilovoltage, 11 kilovoltage, 22 kilovoltage, and 33 kilovoltage systems are normally called as medium voltage cables. These types of cables are normally applied in urban distribution, industrial plants, underground residential distribution, and renewable energy integration. The types of insulation used are normally the synthetic materials like a cross-linked polyethylene or ethylene propylene rubber. Then we will see the construction of polymeric insulated medium voltage cables. The typical 6 to 30 kilovolt distribution cable consists of the different layers like conductor screen, insulation, and insulation screen, then metallic screen, weighting, which is also called a separation layer, armor, this is an optional one, then outer sheet. What are the key properties of polymeric insulated cables? Electrical properties, thermal properties, mechanical properties, and the environmental properties. We can compare the polymeric insulated cables with the paper insulated cables. The polymeric insulated cables are more advantageous compared to paper insulated cables. The advantages are the polymeric insulated cables are lighter and more flexible. The installation as well as joining are very easier, better thermal performance. There is no requirement for oil impregnation. The service life is very longer and typically 30 to 40 years. What are the applications of polymeric insulated cables? Normally, they are used in medium voltage power distribution like urban grids, industrial networks, then underground residential distribution, renewable energy connections, as well as substation interconnections. What are the standards and testing used for polymeric insulated cables are IEC 60502-2, IS 7098 Part 2. The testings normally followed are routine test as well as type test. Next, we will see the manufacture of distribution cables. Distribution cables are manufactured in a step-by-step process that ensures their mechanical strength, electrical reliability, as well as insulation quality. The first step is conductor preparation. That is, the material used for the conductor is high conductivity and either copper or aluminum. The process is the continuous casting and rolling into rods, wire drawing to require diameter, expanding to increase flexibility to reduce the skin effect, sometimes compacted to minimize voids and optimize current density. The second step is conductor screening. A semiconducting layer is extruded over the conductor for the purpose of smooth the surface and elevate the electrical stress concentration points. It is applied by extrusion under controlled temperature and pressure to ensure adhesion and uniformity. The third process is insulation application. The insulators are normally made up of the materials like cross-linked polyethylene or ethylene propylene rubber. The fourth step is insulation screening. A second semiconducting screen is extruded tightly over the insulation in order to provide a smooth boundary for the electric field and allows proper contact with the metallic screen. The next step is metallic screen with copper tapes or wires helically wound around the insulation screen, which provides a path for charging current and ensures shielding. Sometimes, which is combined with water blocking tapes or powders for moisture resistance. The next step is provide the bedding or separation layer, which is the extruded layer or tapes applied over the metallic screen, which it protects the metallic screen from corrosion and separates it from armor. Then one optional step is there is armor, which is applied for mechanical protection, mainly for direct to buried or industrial applications. Steel wire armor is normally used for single core low voltage cables, aluminum wire cables for single core medium voltage cables. Normally, multi-core cable steel is a common one for as a acting as a arm. Next one, outer sheet. Extruded sheet of PVC, PE, or low smoke zero halogen materials are used for the outer sheet in order to protect against mechanical damage, UV, moisture, and chemicals. Testing during and after manufacture. There are varieties of tests are conducted during as well as after the manufacturing. First one is routine test, which is used to test the conductor resistance, partial discharge, high voltage withstand, as well as insulation resistance. The second test is type test, a heating cycle test, bending test, impulse withstand test, and fire resistance test. The next one is cable finishing. Cables are cut into standard drum lengths, coiled on wooden drums with the protecting wrapping, proper marking for size, type, voltage grade, and manufacture. The next topic is manufacture of distribution cables. The summary of the manufacture of distribution cables are the manufacture of distribution cables involves conductor preparation, extrusion of insulation, screening, metallic layers, mechanical protection, sheeting, testing, finishing. Each stage ensures the cable's electrical performance, durability, and the safety. Then we will see the joints and terminations for distribution cables. Distribution cables are manufactured in fixed to achieve longer range or connect to equipments. Joints and terminations are used. They must contain electrical integrity, mechanical strength, and environmental protection. What is meant by cable joints? The cables are joined by means of two methods. One is straight joint, also called as the row joint. Next one is called as a branch, that is T or Y joint. Construction, conductor connection, insulation restoration, metallic screed connection, and outer protection. What are the joining methods used? The first one, feed swing joints, full swing joints, as well as dressing cast joints. Cable terminations means which is used for the purpose of connecting the cable ends to transformers, switch gears, overhead lines, and substation bus. In order to ensure smooth transition of electric field at the insulation cut. Types of terminations are indoor termination and outdoor termination. The techniques used for the terminations are heat string termination, cold string termination, compound termination. Design considerations are while designing the terminations, one has to consider electrical, mechanical, environmental, as well as safety procedures. Standards used for joining as terminations are IPC 60504 as well as IS 1357. Summary of joints and termination for distribution cables are joints are used to extend or branch cables. Type include straight and branch joints. Methods include string, whole string, receive. Terminations are used to connect cables to equipments classified as indoor-outdoor, requires stress control and sealing. Both are critical for reliability, safety, and longevity of distribution systems. Testing of distribution cables. First, we have to see what is the purpose of testing. In order to detect the manufacturing defect, ensure the quality and compliance with the standards, verify electrical, thermal, and mechanical performance, detect damage during transport, installation, and operation, prevent premature failures in service. What are the types of tests used for distribution? Sir, first one is routine test. These types are done on every cable in fact. There are varieties of tests are conducted. First one is conductor resistance test. Second one high voltage test, also called as direct resistance test, partial discharge test, as well as dimensional visual inspection. Then next one is type test. These type of tests are done on prototype cable design, bending test, heating cycle test, impulse voltage test, short circuit test, and water penetrance test. The third test is acceptance test. This is done on samples from batch supply. The high voltage test, insulation resistance measurement, partial discharge test, as well as dimensional construction. The next one is on-site or commissioning test, normally performed after leaving the campus before erasing. Insulation resistance test, also called as mega test. High voltage test, also called as variable frequency or AC test. Sheet changeability test and the continuity test. Next, diagnostic or in-service test, hand delta test, also called as dissipation factor test, partial discharge measurement, thermographic inspection. Standards for cable testing are IEC 60502, IEC 60840, IS 709. Testing of distribution cable summary. Routine test, type test, accept test, on-site test, diagnostic, or in order to ensure the quality of the distribution. Thank you.